How stars die is an interesting phenomenon, although it's quite impossible to see one happen up close. Nevertheless, a powerful imagination will enable you to imagine just how stars would die based on the following information. What is a star? Before learning about the process of death for stars, it's important to know exactly what stars are first. A star is made up of plasma. Although it's definitely bigger than everything on Earth, stars appear in a range of sizes, so some might still be described as small while a few might be described as massive. One good example of a star is the Sun, which is the center of the solar system and the source of the majority of life on our planet. Size isn't age. The Sun, although technically huge in size, is actually considered small when compared to other stars. It also contains a lower quantity of mass than other stars, and that's why it has continued to exist for so long. From that, you can probably derive that there's an inversely proportional relationship between a star's mass and its life cycle. The fewer mass a star has, the longer its life cycle, and vice versa. How stars are born. A nebula is always described as a cloud of dust and gas particles that when combined together forms a star. How much matter exists in its nebula will determine its mass and consequently its life cycle. How stars live and die. As time passes by, gravity will cause particles of hydrogen in the star's nebula to form a smaller and tighter circle. Gravity will also cause the star to start spinning and proceed to spin faster and faster. The speed of which a star is spinning will eventually cause it to transform into a protostar. When the temperature of the star hits 15 million degrees, nuclear fusion will form within its center. Nuclear fusion is a process in which a group of larger-sized nuclei will combine together but have a lower amount of mass. Nuclear fusion is a star's source of power or energy, and it is also what causes stars to emit electromagnetic radiation. Because of nuclear fusion, the nebula within a star will gradually emit a bright glow. It will also diminish at the same time. After a while, a star will stabilize and transform itself into a main sequence star. This is the longest stage in a star's life cycle, and it is also the stage where the Sun is at present. During this stage, a star will be able to glow or shine for millions to billions of years depending on its mass. Hydrogen is the cause and source of nuclear fusion, and every time it's used, it's being converted into helium. Stars, however, don't have an inexhaustible supply of hydrogen, and when the source of hydrogen gets exhausted, the star will naturally be unable to generate heat through nuclear fusion and consequently, electromagnetic radiation. When this happens, the star will become unstable and start contracting once more. The external shield of a star, which is generally made up of hydrogen, will then be used to allow the star to experience nuclear fusion. But of course, this will run out in time as well. While the star is making use of its last supply of hydrogen, it will start expanding, cooling down, and turning red. The change of color then marks the next stage in a star's life cycle, becoming a red giant. The term red giant is very much an apt term to describe what the star has become at this stage. Mass and death. Remember how it was mentioned previously that mass affects the life cycle of a star? And so it does, and this is how you can expect different types of stars to die. For a star with a low amount of mass, the helium that it produced from nuclear fusion will be converted into carbon but causing its core to collapse eventually. When this happens, the star will shed off its external layers and this will form a planetary nebula. The star's center, on the other hand, will transform into a white dwarf, and when its temperature goes down, it will become a black dwarf. As for stars with high mass, generally 10 times bigger than the Sun, they will endure a massive explosion after becoming a red giant. This event is referred to as a supernova explosion. Smaller stars will become a neutron star. Bigger stars will become the dreaded black hole.